Hello. So today we are going to see a difference between notify and notify all. Okay. I just try to demonstrate with the small example. The very simple example I have taken is printing number 1, 2, 3, 1, 2, 3 in a sequence. So what are we going to do is there will be one thread which keeps on printing 1, another thread which keeps on printing 2, another thread which keeps on printing 3. We have to synchronize all of them so that the order of the printing will be 1, 2, 3, 1, 2, 3, 1, 2, 3. For that we have created 3 threads, thread 1, thread 2 and thread 3. Thread 1 always prints 1. Similarly, thread 2 always prints 2. Thread 3 always prints 3. We are sharing one object, one shared object between all of them, which is the printer number. And sorry, the number printer. Number printer has one method called print number, and this is the resource which is going to be shared. This object is shared across all 3 threads. How it is done? I have created object of number printer with the number 3. That means to say the maximum number of threads which it is going to synchronize is 3. Okay, it is just internal. You can extend it whatever way. And then when I created this object, I have shared this object, the same object, to all 3 threads via a constructor. So they are setting this value. So all of these threads are working on the same object reference. Now what happens? I start all of them. When I start, the run method will be called. One of them, whoever gets first chance to run, will run, and will call the print number method of a printer object. So I go here. So the simple explanation for this method is the initial value for the next thread ID will be 1. Okay, and when a thread arrives, we will match with number it has passed. If it matches the expected initial ID, we will print that number and increase the next thread ID to 1, so that we will be expecting the next thread ID. The one boundary condition is if the current thread which has arrived is number is 3, then we will reset the value to expect the next thread as a number 1. Okay, so that will go so that's how it will go in the cycle 1 2 3 1 2 3 1 2 3. So this is the simple explanation for this, simple logic explanation for this method. I'm going to run it. I'll clear this previous thing. Okay, and we'll run it. So it prints and it goes into the infinite loop. You see, it is not terminating. So let's examine one by one what is happening here. First, all three threads have been started. Okay, the first thread which gets the chance to go inside this method is thread 1. That's why 1 is printed here. So it comes here, it checks if it is not the current, it matches the condition, and it prints the number. And then I'll try to explain the same with the output, some PPT here. So expected thread for the first time is 1. The first thread by chance arrives is thread 1. So well, it's good, it prints and notifies. Okay, how it notifies? After executing this synchronous block, as soon as the synchronous block is finished, automatically notify will be called. Notify will be called, not notify all. If we have mentioned somewhere notify, okay, then that time notify will be called. If we have mentioned somewhere notify all, then the notify all will be called. The difference between the notify and notify all is, in the notify all, it always notify only one thread, okay, which is blocked and which is waiting to acquire the lock on this object, whereas in notify all, it notifies all the threads which are blocked and waiting to acquire the lock of this object. Okay, so here since we have not specified manually any notify command or notify code, once the synchronized blocks ends here, automatically one notify will be issued, and depending upon the CPU scheduling algorithm, one of the threads will be woken up and will go to the running state again, or should I say runnable state again, from runnable to running state. Okay, so in this case first we got 1. Okay, 1 matches our condition because we are waiting the next thread ID we are waiting as a 1, so it satisfies. We print and we change the next waiting the next thread ID as a 2. So you see here we print and then we change the expected thread ID to 2. Okay, then what happens? Then if you see the log here, next expected thread ID is 2. Then thread 1 goes to wait state. By this logic of thread execution, the CPU again allows thread 1 to come back here. It acquires the lock of this object again, but we are not expecting thread 1, we are expecting thread 2. So when it comes, it doesn't match our condition, so it goes to the waiting state. Okay, then if you see next, thread 3 goes to waiting state. Then by this algorithm, CPU schedule algorithm, thread 3 comes in. Okay, but we are waiting for the thread 2, so this one also goes to the waiting state. Okay, then what we see here, 2, so 2 comes. Okay, so good, it should match our condition when 2 comes, and we print it. We print, and after printing we increase our expected thread to be 3. Okay, and then automatically it notifies one of the threads which is waiting here. Okay, it is expecting 3 and it notifies one of them. When it notifies one of them, in our case it notifies only one, which is thread number 1. Okay, so thread 1 goes out and thread 3 still holds and thread waits in the waiting state. Okay, no one has notified it. Okay, then what happens? As per our output, we will see that thread 2 comes again. Okay, but we are expecting for thread 3, so thread 2 will also go to the waiting state. Now nobody is notifying anyone. Okay, because we are not able to satisfy our condition, like when the thread number is 3. So after this, thread 1 will also come, which will also go to the waiting state, so it will go there, and thus all this thread will be in a waiting condition, waiting for the acquiring the lock, whereas we are still waiting for number 3. So this is the problem with the notify. So instead of using notify, that we have used default notify here. As you know, once the synchronous block is over, the default notify will be called. Instead of relying on the default notify, we are going to use notify all, like this. So let's see what happens when the notify all is used. So the moment we print 2, okay, we get 2, we print 2, and then instead of saying notify, we say notify all. So both will be woken up, both the threads will be notified. They will move, once they are notified, they will move from blocked state to runnable state, and we'll wait for CPU to allocate them a CPU time, and then when they get a time to run, they will go to the running state, and then they will come back again to execute this method. That would have solved our issues. Okay, so we have modified our code to replace notify with to replace default notify with notify all. So let's run the code and see what happens. So let's run it. You can see it started printing 1 2 3 1 2 3 1 2 3. That's the only difference it is. That this is the main difference between notify and notify. It can create this much of difference. Thank you for watching. So if you like this video, please give a thumbs up, and if you think it's worth sharing, please share it. Thank you.